Hello everyone, welcome back to Imaginary Hub. In the last class, we have talked about what are arrays, how to use arrays, how we can create arrays in Java, and we did little problems on searching, like we did a linear search, binary search, and largest element present in the given array. Now in this class, what we are gonna do is that we will level up and we'll solve more problems based on the concept of the arrays. So without any further ado, let us directly go deep dive into the problems. So I'll open my whiteboard here. So in the whiteboard, like first of all, let me write key what are the problems we will be solving in this class. So I have 5 to 6 important problems. You can find these problems in various different coding platforms like HackerRank, LeetCode, or different platforms. You can find this. These are very simple, easy to understand, and important problems. So let me go down. The first problem is a very simple problem, which is reversal of an array. Reversal of an array. This is going to be our first problem, and the next problem will be what problem? Pairs in array, like printing pairs in an array, and after pairs we'll print subarrays. And there is a concept called as subarray sum, which is really interesting. So we will talk about subarray sum, and in that we have something called as optimized solution. So here we will solve this question in 3 different methods. One is brute force, where we will apply our like basic logical interpretation that we get from the understanding of the question, and the next one is like iterative approach, and we will study a new type of algorithm called as Kadane's algorithm. So in Kadane's is the optimized algorithm of calculating subarray sum for the given array. We will see what is subarray, how to get subarray, after getting subarray how to get the sum, maximum sum, right, maximum subarray sum. And after that we will talk about a famous question, which is best time to buy stocks. Best time to buy stocks. So this are the questions which we will be doing in this class. So how many questions total? 1 2 3 4 5 6 and 7. So total 7 questions. So let us proceed with the very first question, which is reversal of array. So to understand this question, let me tell you ki, let us say we have a array 1 2 3 4 5. This is the given array. This is our first question. This is the array given by our user. Now in this array we need to reverse the array, right? So our resultant, our solution will be, our result will be 5 4 3 2 1. This should be our result. Now the catch here is that if you think logically, like you might say, Jabir, like create a new array. Like if we go with our basic intuition, you might say ki Jabir, create a new array. We'll create a new array of the same size. How many elements? 5 elements. So we will create a 5 elements array. So let me create it. 2 3 4 5. Now what we'll do is that we'll run a loop from the last of the array. So we'll run our loop for I is equals to n minus 1, which is the last index, to 0, and we will take the element at each ith element and we'll insert that in the new array. But the catch in this reversal array is that in reversal array we should not use, or we should not create new space. This is the condition. So how we can do this? So if you notice, let me go here and let me draw the array again. So 1 2 3 4 and 5. Now what are the conditions we have? We should not create new space, and that should be optimized. The time complexity should be optimized. If you don't know something about time complexity and space complexity, I will just put the link of the like top video on YouTube. You can go and directly watch it. But for now we will cover, in future classes we will cover what is time complexity, what is space complexity, and all that. But for now, just understand that time and space complexity are used to calculate how optimized our code is. Okay, so to tell the efficiency of a particular code, we use time and space complexity. Simple, very clear. Now what we will do, we should not create new space. It means that creating a new array is not option. Now if you observe very clearly, let us say that this is our resultant, right? The resultant is 5, 4, 3, 2, 1. So can I say that the last element and first element will swap? It means that the last element will take the first element position and the first element will take the last element position. Okay, good. Now the second last element will take the second element position and second element will take the second last position. It means that the ith element, which is starting index, and the last index will get swapped. After it we will move the iterator, here also we will move the iterator, and again we will swap. Like this we will swap the entire array until we reach the mid value. So we will continue this swapping process until we reach the mid value. So if I tell you, the basic logic we'll get is that we'll run a loop, we'll run our iterator from I is equals to 0 to n divided by 2. Here n represents the size of the array. So I will run the loop for I is equals to 0 to uh, n divided by 2, which is the mid value. I will run the loop for half of the array. Now for this half of the array I will take the each element. So I will take this element and I will take the last element. I will swap them. After that I will move here and again I will move here. So if you notice that we are running a loop, and this loop will run till half position of the array, and what we are doing is that we are taking the first half elements and we are swapping it with the second half, the last end of the given array. So what is the logic? So the logic here is, just observe the indexes. Indexes is the main thing here. So 0, let me write elements 1, 2, 3, 4, 5, and the indexes are, for this array the indexes will be 0, 1, 2, 3, 4. So can I say that the first element will have, first element index is 0 and the last element index will be, total size is n, so it will be n minus 1, which is 4. Its size is 4. Now the second element will have index 1, and the second last element, the half part, will have index 3, and similarly the third element will have index 2, and the third last element will also have index 2. So can I tell that if my iterator starts from I is equals to 0, so here I know that the first element can be accessed through ARR of I. Now how can I access the second half element? That's the question. If I can able to access the first half and the last half, the second half of the element, then I already know how to swap elements, right? So here just observe that the element is decreasing by 1. So can I write here, you can see our iterator is increasing by 1 and the second half is decreasing by 1. So can I write the formula for getting the second half elements as n minus 1 minus I? So the to access the second half elements, can I write them as ARR of n minus I minus 1? So if I can able to access the first half element and the second half element, we already know how to swap elements. So what I will do is that I will swap these two. So here let me write the code, let me write the pseudocode, and I will directly go to the code part of that. So what I will do is that I will create a temporary variable. So int temp is equals to ARR of ith element. Now what I will do here is that in the ARR of ith element, first of all I will put this in temporary value, and ARR of I is equals to ARR of n minus I minus 1. After that, in the ARR of I minus n minus 1 position, n minus I minus 1 position, I will put the temporary value. So this is the classical code for swapping. Like this I can like reverse elements in the given array without creating extra space. I hope you have understood the logic behind it. So I have noticed that reversal is basically swapping elements. We'll swap the first element with the last element, second element with the second last, third element with the third last. Like this swapping will happen, and this swapping will continue until I reach the middle value, until I reach the middle index. So what I'm doing is that I will run the loop for half of the array. Okay, and while I'm running this loop, I will take the first element, I will take the last element, and I will keep swapping them until I reach the mid value, which is the termination condition for my loop. As simple as that. Now let us go into the code part and code this thing. I know this is like little bit interesting, and now we will be going into deep dive into questions, you will see. So what I'll do is that I'll create a new file called as q2.java. Now here, first of all, let me import my code, import my boilerplate code, import java.util.star. Now after this, I'll write my class q2, and here let me remove all these things. So I'll create an array. Let's say I'm creating array int arr is equals to 1 2 3 4 5. Now what I will do is that I'll create a function for reversal. So here let me create a function public static, let's say void reverse array, and you can see it is giving me inbuilt code. I don't want inbuilt code, I will write my own code. So what I'll do is that I'll run my, first of all I'll run my loop half of the array. So I'll run for int I is equals to 0 and I should be less than arr dot length divided by 2. You can see it has given me the code, and what I am doing, I am swapping the elements. So let me write arr dot length divided by 2. So here what I am doing, you can see that I am running my iterator I is equals to 0 and I am running that loop till half of the array. Now what I will do is that I'll keep running my loop, and I will take the first element, put it in temporary value. I'll take the first element, put it in temporary value. Now in the first element, I'll take the ith element, put it here, and in the ith element, I'll put this temporary value. Like this swapping will happen. So I'll keep on swapping the first half of the array with the second half until and unless I reach the middle value. So this is the code of swapping. Okay, now after swapping, what I'll do is that I'll just print my reverse array. So here I'll print my reverse array like this. Okay, let me close the loop here. Yeah, let me just save it and run. So I'll go here, I'll go into array cd arrays, and in arrays I will run my java q2.java. I hope this will run. Last time we had a lot of problems while running it. So what I'll do is that first of all, in the main function, I'll give the reverse array function and I'll pass my creation array. So my original array is 1 2 3 4 5. Now when I call my reversal, it should reverse my array and it will give me the output as 5 4 3 2 1. So let me save it and run again. It is showing some sort of error. Okay, my bad. Every time, there's not a single time where I don't make a mistake. Goddamnly. Let me refresh it, really clear, and run my loop again. So you can see my output is 5 4 3 2 1. Like this we print the reversal of the array. Now if I ask you, okay, what is the time complexity, you might say, Jabir, if we are running the loop from 0 to n, last element, then the time complexity will be big of n. But here we are running our loop half of the time, right? We are just going to the mid value, so the time complexity will be big of n by 2. But let me tell you this, that there is nothing called as big of n by 2. Big of n by 2 is also considered as big of 1, big of n. So it will give me a linear time complexity, you can say. Okay, we will talk about what is big of omega, theta, all this sort of things when we study about time complexity and space complexity. Here the space complexity is big of 1, which is constant space, and the time complexity is, let me write it here, let me write here, space complexity here is big of 1, and time complexity here is big of n. Okay, I hope you are clear. for every code, I'll try to give you the time complexity and space complexity of that. If you remember, for linear search, the time complexity is big of n, because we are going, if it is a worst case, we'll go to the last part of the array. Okay, so that is it. For binary search, we are breaking down array into different parts, right? So for that, for binary search, the time complexity is big of log n. Okay, so this is about it. Now let me go to the next question. The next question is pairs in array. This is an interesting question as well. So let me little bit zoom out. Okay, this is nice. Okay, so the next question is pairs in the array. Pairs in an array. Pairs is nothing but we have seen couples in our college, right? So if two people combine or two elements combine, then we call it as a pair. Okay, so let us say that we have been given an array, and the array is 1 2 3 4 5. Simple, very simple array. Now for this particular array, the pairs will be 1 2 and 1 3. One will have pair with, one can have pair with each element, right? So 1 4 1 5. After 2 can have pair with 1, and there is already, you can see, if I write 2 comma 1, 2 comma 1, 2 comma 1 is already a pair here. So if there is already a element present, if there is already a pair present, then I don't need to write that. So what I will do is that 2 3 is a pair, 2 4 is a pair, and 2 5 is a pair. Similarly, 3 4 is a pair, 3 5 is a pair, and finally 4 5 is a pair. So for the given array, right, the question here is we need to calculate the pairs that can be possible for that given array, and we need to print each of this pair. I hope you have understood what is pair. Okay, now how we can solve this question, let us understand. This is our array, given array 1 2 3 4 5. Okay, my bad, my diagrams are always so bad. Okay, let me put it up there. Okay, thank god, man. Okay, this is the given array. Forgive my bad handwriting, I know that. So here you can see that the pairing here, these are the pairs. Let me draw such that you will not get confused. I need to improve my handwritings, I know that. Okay, so you can see that first of all we'll calculating the pair of ones, pair that can be possible with 1. After that we are calculating the pairs that can be possible with 2. After that we are calculating the pairs of 3, the pairs of 4. Like this, we are first of all taking the first element, and with this element we are comparing other elements. Okay, so if I draw diagrammatically, first of all I'll take this element, and with this element I'll try to calculate the pair with all other elements. So can I say that I will create two iterators? I will create two iterators, let's say I comma j. Okay, and I will keep track of which element, you can say which element I'm at right now, or you can say which element I have fixated, which element I have fixated. You can see initially I have fixated 1, and with respect to 1 I am calculating the pairs that can be possible with respect to 1. So j represents the elements with respect to I. And observe one thing, that if this is I, okay, if this is I initially, if I is equals to 1, then j is equals to, j is changing every time. You can see j is equals to 2, j is equals to 3, j is equals to 4, j is equals to 5. So can I write that if the index, not index, if the element, let's say the ith element is 1, then the next immediate jth element will be 2. After making the pair 1 comma 2, I will increment the value. I will go to 3. After that I will go to 4. After that I will go to 5. Now after making all the possible pairs that can be possible with the fixated pair, I will update. After, let me write it here, after calculating all the possible pairs, let me put it here, with respect to fixated, ith value. After calculating all the possible I comma j value, what I will do is that I will increment the I value. And after incrementing the I value, you can see, let me erase it here. So after calculating all the pairs of 1, what I will do, I will just, let me remove all this. Okay, so what I will do now is that I will make my fixated iterator as 2 now, and with respect to 2, I'll start making pairs 2 3 2 4 2 5. So can I say that if the index of I is equals to 0, then the initial index of j will be 1. If I is equals to 1, then j initial index of j will be 2. So from this, can I say that if I is equals to n, then j value will be n plus 1. Okay, clear? I hope you have understood how we are getting the I and j value. Now what is the pseudocode for that? So what we'll do is that we'll take the ith iterator as an outer loop, and we'll take the jth iterator as the inner loop. So let me write the code. When I write the code, now you'll get a very clear picture of how things are working. So I will run my outer loop. My outer iterator I is equals to 0 to n, and inside that I will run my jth iterator for j is equals to I plus 1 to n, and I will print system.out.print my fixated iterator, which is I, and the changing iterator, which is j. Like this, I'll print the pairs of each element. I hope you have clear. So let me give you a very brief summary of this question. The question is, we need to calculate the pairs for the given array, and pair is nothing but combining two elements. Okay, 1 2 or 2 1, basically the same pair. So what we will do here is that we will take the first element as a fixed iterator, and with respect to this fixed iterator, we'll combine each element. We'll keep changing and we'll be combining that. After combining all the possible elements, we'll change the fixated iterator. Very simple. Okay, now let me go to the code and write the question here. So here I'll create a function public static void, and let's say pairs, right? Pairs, PIRS, pairs of array, and user will give me array. And what I'll do is that this is my outer loop, and here we have a fixed element. Okay, let me fixing one element, right? We will fix the whatever the elements we are at now. After it, we will move inner loop, will traverse the rest of the elements. Okay, now after this, what we'll do is that we'll print the ith element and the corresponding jth element, and this iteration will continue until we reach the last jth element. Now after reaching the last jth element, we'll increment the fixated element, and with respect to this fixated element, we'll continue iteration again. Like this, the looping system, the iteration will work. Now what I'll do is that in the place of reversal, we'll give the print pairs of the array. Now let me save it and run the question again. So when I run it now, it will give me 1 2 1 3 1 4 1 5 2 3 2 4 2 5 3 4 3 5 and 4 5. So let me see. You can see 1 2 1 3 1 4 1 5 2 3 2 4 2 5. Like this we can calculate the pairs of the given array. I hope you have understood. Now the next question is very similar to pairs, but here we are going to print subarray. Okay, here another interesting question, subarray, right? So let me write the question here, subarray. And this is a very classical question, believe me when I say that. You will find this question in various different forms. For example, you will find subarray, like question related to subarray. You will find question related to Subarray Sum, and in Subarray Sum we have three different variations. One is brute force, one is iterative approach, one is Kadane's algorithm. And based, if you have a clear understanding of how Subarray Sum works, believe me when I say that, there's another question called as I can't remember the name. Oh shit, I can't remember the name. I think like the user will give the rotation of the array. Like through subarray sum will go to the rotation of the array. So this is an important problem. So let us say that user has given me array 1, 2, 3, 4, 5, and our task is to print the overall possible subarrays for this question. Now you might ask, okay Jabir, we have understood what is pair because we are living in college, we have couples, we are couples, right? So, but tell me, what are subarrays? What is the meaning of subarrays? So the definition of subarray is that it should be a subset. Subset is nothing but 1 is a subset, 2 is a subset. Basically, the elements which are the which is the part of the given array. This is first condition. And the next part is it should be in continuous format. Continuous format. If these two conditions are satisfied, then the given element is a subarray of the given array. Now let me first of all show you ki for this particular array what are the subarrays. Okay, so here we have elements 1 2 3 4 5, right? For this given array, the subarrays will be, let me write, 1 is a subarray because 1 is a subset and 1 is a continuous part. 1 2 is a subset because subset and it is continuous, it is going in this order. Okay, now 1 2 3 is a subarray. 1 2 3 is a subarray. 1 2 3 4 is a subarray. 1 2 3 4 5 is a subarray. Now you might ask here, if I write 1 2 4, this is also a subarray, right? No, it is not a subarray because although it is a subset, but it is not in continuous fashion. You can see 3 is missing here. That is why it is not a subarray. Subarray is that first of all it should be a subset, which is basically the part of the array, and it should be in continuous fashion. That is why 1 to 4 is not a subarray. Now after this, 2 is a subarray, 2 3 is a subarray, 2 4 2 3 4 is a subarray, 2 3 4 5 is a subarray. Okay, similarly 3 is a subarray, 3 4 is a subarray, 3 4 5 is a subarray, and 4 is a subarray, 4 5 is a subarray, and finally 5 is a subarray. Like this the total possible subarrays are here. Okay, got it. Now here comes the question, how we are gonna solve it. So to solve it, I want you to observe something. Observe the overall subarrays we got. So if you observe, you will see that I have two iterators. I have the starting element and the ending element, and whatever the elements present in between that, I'm printing that. Okay, so here you can see that for this the starting element is I is equals to 0. Okay, let me write it here. Let me write it very clearly. For this particular subarray, the starting element is I is equals to 0 and the ending element is also 0. And whatever the elements present in between them, we are printing that. Now here you can see that the starting element I is equals to 0. Okay, the index of this is 0 and the ending element index is 1. And we are printing the elements from 0 to 1. Okay, now here you can see that the starting element index is 0 and the ending element index, which is 3. You can see 0, 1, 2, 3, 4. Okay, so for 3 the ending index is j is equals to 2, and whatever the element present from I is equals to 0 to 2, we are printing them. Okay, here you can see for this particular array the starting element is I is equals to 0, and you can see that the index of 5 is 4. So here it is 4, and from 0 to 4, sorry, from 0 to 4, whatever the elements present in between them, we are printing that. So can I write that we will be running two iterators? One will keep track of the starting, like we will be running two iterators overall on the, if we see from the top, if we see from the bird's eye view, we will be running two iterators. One will keep track of starting index, and second will keep track of the ending index, and whatever the number of elements here, whatever the number of elements will be present between starting to ending. Okay, we will print those elements, and this is nothing but our subarray. Okay, so what we'll do here is that first of all the outermost loop will keep track of starting element. So I will run a loop. This is my starting element. The first loop is for calculating the starting index of the element. So I will run the loop for I is equals to 0, to n, and after that I will calculate the ending element. Okay, so before that let me put the ith value as a starting index. So I will write int start is equals to I. Okay, now I will run my ending index. The next loop will keep track of my ending index. So I will run for j is equals to, it is also running, you can see here j is also 0. So I'll run my loop for j is equals to 0 to n, and here I will calculate my ending index. Ending is equals to j value. Now what I will do, I will run my deep inner loop. This is, I will run another loop, and here I'll run my for k is equals to starting index to ending index, and whatever the elements present here, I'll print those elements here of k. Like this we will print the subarray. I hope you have understood the logic behind it. Like we will be running three loops. One will keep track of the outermost element. Number two will keep track of the ending element. Like one will keep starting element track. The inner loop, the second inner loop will keep track of the ending element, and whatever the elements present in between it, we will be printing that. Okay, so I hope you have understood key how things works. Okay, so what we'll do here is that let me directly print the loop. So what we'll do is that we'll write our class public static void, and here we need to print the subarray, right? So I'll write print sub array. Now here you can see that I'm running my, this will keep track of the starting index, right, starting point, and this will be our ending point. And what we will be doing is that we'll be printing the elements from the starting index to the ending index. For your clarity, let me write int start is equals to I. Okay, now here I'll write int end is equals to j, and here let me change start strt start and I'll be going till end, and let me save it and let me run it. I hope this will work. Let me comment this out. Okay, now what I'll do here is that key, let me directly print my subarray. Let me save and run it here. So it should give me all the subarrays. You can see 1, 1, 2, 1, 2, 3 like this. And here we are running 3 loops, right? The outer loop, which will keep track of the starting elements, inner loop, second inner loop, which will keep track of the ending point, and the third inner loop, which will print the elements from the starting point to the ending point. So the overall time complexity will be big of n cube. Okay, and space complexity will be big of n, because we are not going to create any extra space, but time complexity will be big of n cube. It's a cubic time complexity. Now the next question here we are going to do here is subarray sum. Okay, this is a very interesting question, subarray sum. Now for subarray sum, like it is a variation of subarray itself. So for subarray sum, what we will do, we will calculate the, let me draw here, let me explain you what is subarray sum, and after that we'll go into the questions, right? So let me write a array. The question is maximum subarray sum. Okay, let's say user has given me a array 1, 2, 3, 4, 5. Okay, now the question here is that we have subarray, we already know how to calculate subarray. So I will write 1, 2, wait a second, 1 is a subarray, 1, 2 is a subarray, 1, 2, 3 is a subarray, 1, 2, 3, 4 is a subarray, 1, 2, 3, 4, 5 is a subarray. Similarly 2 is a subarray, 2, 3 is a subarray, 2, 3, 4 is a subarray, 2, 3, 4, 5 is a subarray, and 3 is a subarray, 3, 4 is a subarray, 3, 4, 5 is a subarray, 4 is a subarray, uh, 4, 5 is a subarray, and 5 is a subarray. Now the subarray sum tells me that for each element calculate sum. Okay, for each element we'll calculate sum. The sum of this array is 1, the sum of this array is 3, it is 5 plus 1, 6. Here we'll have 5, 5 plus 1, 9 plus 1, it will give me 10. Here I will get 15, here I'll get 2, 5, 7, 7 plus 2 is 9. Here 9 plus 5, which is 13, uh, which is 14, 14, my bad, 14. Here 3, 7, 9 plus 3, 12, 4, 9 and 5. Now you can say that for each subarray we have calculated the sum. Now tell me which is the largest value. The largest value is 15. So the maximum possible subarray sum for the given array is 15. So our answer would be 15. Like this we calculate subarray sum. Now what is the logic? The logic is very simple. While you are, like, let me write it here. I'll create an iterator here. Let me copy this entire code. I don't know how to copy, but let me try to copy. Okay, can we copy? I don't think so we can copy, but let me write it. So this is the code we have, right? Okay, this is the code we are having. Now what I will do here is that key, I'll copy this code. Okay, I think we have copied it. Okay, let me copy it. Now let me come here in this whiteboard. I hope you have understood what is subarray sum. Now let me paste it here. Now what we will do here is that key, let me put it up here. Now what we will do is that I will create a new iterator. I'll create a new variable called as int. Let me choose my pen. Okay, so int maximum sum, and I will initialize it with minus infinity, and after that I'll create int current sum is equals to 0. Now what I will do is that while printing, instead of printing, let me remove it. Okay, now instead of printing, what I will do here is that I'll calculate the sum. So my current sum is equals to current sum plus ARR of k. It means that whatever the element I'm at, I'll take the sum, I'll put it in the current sum, After that, I'll see if my current sum is greater than maximum sum. If this is the case, then I'll change the current sum to my maximum sum. Wait 1 second. Yeah, current sum is equals to maximum sum. No, I'll change the maximum sum. My bad. Maximum sum is equals to current sum. And finally, after calculating maximum sum, I will print system.out.print maximum sum. So one small change. Instead of printing elements, we're calculating its sum. That's it. And after calculating the sum, we are comparing that our maximum sum, which is minus infinity, is less than the current sum. If it is the case, then immediately change the maximum sum. Simple. Now let me go and code it. So what I'll do is that let me write the code. Public static void print maximum subarray sum. Now you can see what I'm doing. First of all, I'm creating a loop. I'm creating a variable integer dot min value, which is minus infinity. Now the same code, the same I is equals to start is equals to I, and after that I am incrementing the endpoint, and end is equals to j, and I'm creating current sum. Let me write c sum. C sum is basically current sum. Now if my current, I'm incrementing the current sum, C sum I'm incrementing. Okay, now if my current sum is greater than the maximum sum, I'll print the maximum sum. Okay, after that I'll print the maximum subarray value. Okay, let me print it, let me comment this out, and let me print it now. Maximum subarray sum, and we already know that for this particular array it will give me the output as 15. So let me uh, save it first and run it again. Okay, so it is showing me some sort of error. Okay, I need to give c sum here. So c underscore sum, let me save it, clear again and run. So you can see maximum subarray sum is 15. Like this we calculate the maximum subarray sum of the given array by just tweaking one or two lines, changing one or two lines. But there is a problem here, that the time complexity of this thing is big of n cube. It means that let's say let me give you an example. Let's say my array has 1000 elements. This will give me time complexity as n cube, right? So if the n size is 100, or let's say 1000, then my n cube, the number of operations will be performed, will be n cube, which is, we need to add 100 into 100, 1000, right? So 1000 into 1000 into 1000. So how many zeros? 9 zeros. 1 2 3 4 5 6 7 8 9. This many operations I need to perform for 1000 elements. It means that how many ones, tens, hundred, thousand, 10,000, lakh, 10 lakh, crore, 10 crore, 100 crore. So for 1000, let me write, for 1000 elements I need to perform 100 crore operations. This is a very inefficient code. So to tackle that, we have something called as iterative approach, and we have something called as Kadane's algorithm. So let us discuss that. Let us discuss iterative approach first. Okay, so iterative approach tells that, first of all, iterative approach tells that we can solve the given question in big of n squared time. So what we will do, like, let us see the old code. We are running the outer loop, we are running the second loop, and we are calculating the elements. We are calculating the third loop is using to calculate the subarray. Now my question is, if we are calculating sum now, then what is the need of subarray? So here what we will do is that we'll run the loop for I is equals to 0 to n, and we'll create sum is equals to 0, and we'll write for j is equals to 0 to n, and we'll calculate the element till ending index. Okay, so what we will do here is that key will calculate CS, which is current sum, is equal to AR of J, and will calculate if my CS is greater than maximum sum, then we'll print, or no, will not print, we'll change MS is equals to CS. Like this we'll do. Now what we are doing, what is the change we made? Let's say this is the array 1 2 3 4 5. This is the starting index, ending index. We'll calculate the sum directly. We'll calculate the sum. What is the need to first of all calculate the subarray and then calculate the subarray sum? If you can directly calculate the subarray sum, then it's good now, right? So what we'll do here is that let's say this is I, this is J. We'll calculate the sum till J. This is the thing we'll be doing. So let me write the iterative approach. So public static void now you can see this is a more like iterative approach, right? Here the time complexity is big of n square, and the only change we did is that we are not running my third loop. We have removed that third loop. Instead of that, what we are doing is that we are directly calculating the current sum. Okay, so it is the only change we will be doing, and it will give me the same output. So here let me comment out and save it, run it again. So print subarray sum, and we have, I think, maximum subarray. Yeah, it will give me the same thing. Let me save it and run. Yeah, you can see it is giving me the same thing, but this is a iterative approach. Now there's one more question that, Jabir, you have shown me big of n cube, big of n square code. There is another way that we can do this question more efficiently. The answer is yes. You can solve the same question in linear time complexity using algorithm, which is very beautiful, and the name of the algorithm is Kadane's algorithm. So let me show you how Kadane's algorithm work. So let me directly show you what is the concept of Kadane's algorithm and how we can solve the maximum subarray sum in a linear time. Okay, so let me write it, Kadane's algorithm. So Kadane's algorithm tells that the logic here for Kadane's is very simple. Let's say we have a positive element, and you're adding it with a positive element. What is the result? The result will be a positive element. Yeah, this is a good condition, right? Because we want maximum, right? If we are combining two positive numbers, it is giving me a number which is bigger than these two numbers. If we are getting this condition, yeah, you should take this condition. Now if you're combining a big positive with a small negative and you are getting a positive value, this is also a good condition. This is also a good condition. Now here's the question: if you are combining a small positive with a large negative, then the result will be a negative number, right? And why are you choosing this condition first? Why are you choosing this condition? You should delete this condition, because our need is to get the maximum subarray. And if the number is negative, then why you should take it? Because negative is not maximum, negative is not largest. So what we will do, let me take a negative element example as well. I have a negative element with me, I have a sample case with me, right? So let me write a array. Let's say I have a element -2, -3, 4, -1. I have a element in front of my tab, right? -2, 1, 5, 3. So the logic here is that we will create, Kadane's algorithm will tell you you start running your loop. you start running a loop and create current sum and maximum sum. Okay, and initialize current sum with 0. Listen to my words very carefully, that this is the given array. Let's say this is the given array. My handwriting is bad again. Actually, it's not handwriting, it's diagram. Okay, 5 and minus 3. So we will initialize with current sum with 0. Okay, now here you can see this is a negative element, so we will add the current element, which is minus 2 plus 0. It is giving me minus 2. If this is the case, I am getting a negative element. If this is the case, don't do anything. Don't do anything. Okay, so here we will initialize it with 0 and minus infinity, and we'll start our iteration process. If you get a negative element now, then in the place of negative element, change current sum to 0. So we'll put current sum to 0. Now you can see minus infinity is less than 0. If this is the case, then change the maximum sum. So I'll change the maximum sum. Now the current sum is 0 and the element is minus 3. So current sum 0 minus 3 will give you minus 3. If you are getting a negative element, do not do anything. So put it as it is. And the maximum sum will also be this. Now the next element is 4. So for the next element, the current sum will be current sum is equals to 0 plus 4. It will give me 4. Yeah, current sum is now positive. If you are getting positive, then put it 4. And you can see that my maximum sum is 0 and the current sum is 4, which means that my current sum is greater than my maximum sum. If this is the condition, okay, let me close it. My bad. Okay, so if this is the condition, cancel, then change the maximum sum. I'll write it 4. Now after that, current sum is 4 and the element is minus 1. So it will give me 3. 3 is not greater than, current sum is 3 and 3 is not greater than 4. So I'll put it 4. After that, I'll come here. So 3 minus 2 will give me 1. So here 1 and my maximum sum will remain same. Now the current sum is 1. Current sum is 1 and the element is also 1. So 1 plus 1 will give me 2. So the current sum will become 2 and maximum sum is greater than current sum. So it will remain the same. Now the current sum is 2, element is 5. So 2 plus 5, it will give me 7. Now 7, which is current sum, 7 is greater than 4. If this is the case, update maximum sum. After that, 7 minus 3 will give me 4 and maximum sum will be 7. So you can see the maximum sum is 7. Like this we calculate Kadane's algorithm. So let me write here public static void print. I know current has gone, but I'll keep on shooting. I'll at least complete this question and after it will continue when the current is back. So maximum subarray sum, or let me directly write Kadane's algorithm, right? So Kadane's. Okay, so what I'll do here is that key. Current has gone here in the city I'm in right now. So I'll just write Kadans. Here I'll start running my loop. For before that, let me take the parameter. So here, okay. So Kadan's algorithm. It is raining really heavily here. So you can see, first of all, I'm creating maximum sum and current sum. After that, I'm running my loop, single loop, and I'm calculating the current sum. If my current sum is greater than maximum sum, I'm changing the maximum sum. If I'm getting a negative value, then I'm keeping it as it is. Now maximum sum using Kadan's algorithm, it will give me this. Okay, so let me comment this out and let me print my Kadane's algorithm. So Kadane's algorithm, save it and run it here. Okay, you can see the maximum sum is 15 using Kadane's algorithm. Like this, we implement Kadane's algorithm. Now, we have one more question. I hope I'll continue this after we get the current back. So hello everyone, let's proceed with our uh, hello everyone, current is back now. Let's proceed with our final question, which is what is the best time to buy and sell stock such that we'll get maximum profit. So in this question, user will give me stock prices at each day. Now I need to figure out that on which day I need to buy and on which day I need to exit such that I should get maximum profit, right? So this is the asking of the question. Let me give you examples such that you'll understand in a better way. So the question name is buy and sell stock. Okay, so each company has their own, publicly listed company has their unit price called as stock, and what people do is that they buy and sell stocks. So here user will give me a array, or in the question will be given a array. Let's say that array is 7 1 5. I have that example in my book, so I'm saying that 7 5 3 6 4. So these are the prices of stock in the given day. Okay, now what I need to do is that I need to figure out key what is the best time to buy stock and to sell such that my profit will be maximum. So let me show you a graphical representation. Let's say this is my days and these are my prices. Now let's say I'm buying stock at 7. So on Monday the stock price is 7, and Tuesday, Wednesday, Thursday, Friday, and Saturday. How many days? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, 6 days. Now on Tuesday the price is $1. Wednesday $5. Thursday $3. Friday $6, and Saturday Saturday it's $4. So my stock price is going something like this. Okay, something like this. Now what I need to calculate is, the asking of the question is, I need to calculate the maximum profit, that can be billed, for the given prices, for the given prices. Now if I tell you, for example, let's say I bought stock on Tuesday and the price of that stock on that day is $1. So I bought the stock, one stock, on Tuesday. Now let's say I'm selling that on Wednesday. What is the price? The price is $5. So we can tell that my profit value will be, here my profit value will be 5 minus 1, which is my selling price minus buying price, buying price. And here it is asking maximum profit. It means that this value must and should be a positive value. If I'm getting a negative value, then immediately like ignore it. If you're getting a positive value, then put it in the resultant value and like keep iterating. What we'll do here is that this is the array, right? 7 1 5 3 6 4. What I'll do is that here I'll keep two iterators, here. I will create two iterators. The first iterator will keep track of the current day, and the second iterator will go on the next day prices and will subtract at each and every point, and after subtracting we'll see what is the profit. If the profit is greater than the resultant profit, then we'll change the resultant value. So what I'll do here is that, let me write the pseudocode. After that I'll tell you what is going on, how dry run will run. So what I'll do is that initially I will create a variable called as result, and this result will at the end it will show me the result, it will show me the answer. Okay, so I will initialize this result value with 0. Now what I will do is that my first iterator will keep track of the current day and the second iterator will keep track of the next upcoming prices. So what I'll do here is that I'll run my loop for I is equals to 0 to n, and I will run my loop for j. The second iterator will start from the next day. So I plus 1 to n. Now what I will do here is that I will calculate the differences, the profits that can be generated if I buy on day 1. So what I will do here is that I will calculate profit is equals to the array of jth value minus ith value. J is the selling price, AR of I is the buying price. Okay, now after calculating profit, I'll compare whether my resultant math dot max of profit comma resultant. Very simple, very easy to understand. So what I'm doing here, let me show you a dry run. Let's say here this is my array, right? 7 1 5. I am writing very smallly such that I can fill all the things in the screen. So 7 5 3 6 4. Now let's say here my initially resultant is 0 and the current day, right, the buying price which is ith. Let's say my buying price is 7, which is on the first day the buying price is 7. Now the selling price will start. I can, let's say I bought on Monday. If I bought on Monday, then I can sell the stock which I bought on Tuesday, Wednesday, Thursday, Friday, on the next upcoming days. Let's say I bought my stock on Wednesday. If I bought my stock on Wednesday, then I can sell that on the upcoming days, on the next days, like Thursday, Friday, Saturday. I can't sell in the backward. I can't sell, let's say I bought on Wednesday, but I can't sell on Tuesday because time goes in one direction, right? So in this direction only I can sell my stocks. So my initial, let's say I sell my stock on Tuesday. What is the price of the stock? $1. So my profit 1 will be 7, sorry, selling minus buying, right? So 1 minus 7, it will give me minus 6. You can see the resultant is greater than minus 6. If this is the case, then I will not change anything. Here I will get only the maximum value. If profit is maximum, then the result, then and only I will change it. Okay, so on day 1 if I sell it, then I'll get this profit. Let's say I'm selling that stock on Wednesday. So on Wednesday I'm selling that stock. So here what is the price on Wednesday? $5. So 5, and what is my buying price, which is 7? It will give you minus 2. Again it is null. Let's say I bought my let's say I am selling at day 3, which is Monday, Tuesday, Wednesday, day 4, which is Thursday. So here 3 minus 7, it will give me minus 4 again, minus 4. Similarly, let's say I am selling that on last day. The price is $4. So 4 minus 7, it will give me minus 3 again. So here you can see that if I buy my stock on day 1 on Monday, the price is $7. So it is not a good idea to buy stock on day 1. So let's say I'm buying my stock on day 2, which is the price is $1. So when I sell on Wednesday you can see the price is $5. So here it will give me profit on Wednesday. On Wednesday the profit will be 5, which is the selling price minus 1, it will give me 4. Similarly, if I sell on day 4, which is Thursday, the profit will be 3 minus 1, which is $2. If I sell on Friday, the profit will be 6 minus 1, which is $5. Now you can see that here if I sell on the last day, which is $4, selling price minus buying price, it will give me $3. Now you can see if I buy on day 2, the price is $1. The maximum profit which can be generated here is 5. So my resultant will become 5 now. Now what I'll do is that I'll keep on iterating this until I reach the end of the array. So here I'll continue my buying. Now you can see my resultant is storing $5. Let me round off $5. Now let's say I'm buying on day 3. On day 3, what is the price? $5. So $5. Now my profits will be 3 minus 5, 3 minus 5 minus $2, and 6 minus 5, $1, and 4 minus 5, which is minus $1. You can see these values are not greater than the current resultant. The current resultant is storing $5. right? So I will not change it. Now I will move to the uh, fourth day. So on fourth day the price is $3. So $3, let me zoom it out such that you will understand ki what is happening. I'm buying here. Now if I buy here, I can sell on the next day. So selling price is $6 and buying price is $3. So it will give me $3. And if I sell on the next day, it will selling price is $4 and buying is 3, it will give me 1. So you can see 3 and 1 are not greater than 5. If this is the case, do not change anything, move to the next day. So here I will move to the Friday. So on Friday the buying price is $6. Now I can sell only on Saturday. I can't sell on previous days, right? So my only profit will be 4, which is the selling price on Saturday, minus buying price. It will give me -2. You can see -2 is less than 5. So my end resultant, you can see among all these numbers, among -6, -2, 4, -3, 4, 2, 5, 3, the maximum value is 5. So my resultant answer will be $5. Like this we calculate the price, and this is the pseudo code of calculating the maximum price for the given stock. Okay, so let us try to do this question. What I'll do here is that I'll go to Visual Studio Code. Let me zoom it, and I will write the function public static void buy stock, buy and sell stock. You can see it has given me all these things like minus infinity, blah blah blah, and this is a sort of big code. So what I'll do is that I'll remove this everything, and I'll start my code with resultant, the code which we have written. So I will write my result is equals to 0. Now after that I will run my loop till the price of the array, and this is my outer loop. Now here what I will do is that let me run my inner loop as well. So here I will run my inner loop for, I should start from day 0. So day 0 and less than length. Here I will run my loop for int j is equals to I plus 1, and you can see that we are calculating all these things, but we can simplify this code as, I'll calculate profit, int profit is equals to price of j minus price of I. Now I'll calculate resultant is equals to math.max resultant. Now after that we can continue the code like system.out.print resultant value. Now let me save it, and I will give my function. You can see I'm using the like example which we have used just now. Now I have manually calculated key what is the profit of the given array, which is 5. Now if I run the code, it should give me the same answer. So I'll call my buy function, buy and sell stock, and save it. Now run it again. It should give me the answer as 5. It is showing some sort of error, load main. Yeah, I need to go into arrays. So cd arrays. Now it will work. So let me save again and run public static void public string args. Why it is showing error again? Oh, illegal expression. Illegal expression. I don't know what's a legal expression here is. Maybe it's the loop. Oh god, I need to give one more bracket here. 2 brackets, right? So here I need to give 2 brackets here. Okay, save. Now this will work hopefully. Yeah, you can see my output is $5. Like this we calculate the what is the maximum profit that can be generated over the given uh, least of stocks on each day. Okay, so I hope you have understood key how array works, what is array, the questions related to array. We did I think 10 questions based on arrays, and these are the most important and top recurring questions. Now what I'll do is that at the end of the comment session I'll give you a GitHub link through which you can access the entire code, and you can access the concepts as well. At the same time I'll provide you the top arrays based lead code questions in the comment section. So with that being said, I will see you in the next chapter, and the next chapter is going to be sorting algorithms. So it's going to be interesting. See you in the next one.